AC generators are rated by their output capacity. The AC generator's current output may be 80 amperes or more. The power it delivers is often much less than its peak output. With all accessories turned on and the battery charging, the AC generator may be operating at its full capacity. But with no accessories on, a charged battery, and only the ignition operating, the demand for current may be as low as 4 or 5 amperes.
Since electrical systems are fairly standard in modern automotive vehicles, AC generators are almost always equal in voltage and current output. Do you think this statement is true or false? Use your mouse to click on your answer.
True.
Many people say true.
False. I missed that question, but it's true.
It's true.
They said, I mean,
I think it's
I think
false.
it's false.
False. Click false.
That's right.
That's right.
Yeah.
That's right.
Manufacturers determine the type of AC generator required for a vehicle based on the engine type, accessory load, and projected operating conditions. AC generator output is rated in voltage and current. Most automotive AC generators are designed to produce a voltage between 13.8 and 14 volts. The voltage of the AC generator must be higher than that of the battery in order to recharge the battery. Remember, since current must flow into the battery, there needs to be a difference in voltage between the battery and the AC generator. If the AC generator had an output of only 12.6 volts, there would be no potential difference, and no current would flow from the AC generator to the battery. Now let's look at the design of a typical AC generator. The AC generator divides into two halves called the end frames. One end frame is called the slip ring end frame, and the other is called the drive end frame. The end frames hold the bearings that support the rotor and allow it to turn freely within the stator. These end frames contain the moving components of the AC generator and are generally made from a non-ferrous metal such as aluminum. They are usually open in the front and back to allow ventilation while the AC generator is in operation. The pulley is bolted to one end of the rotor by a large nut. Behind the pulley is a fan designed to provide ventilation while the unit is in operation. Inside the two end frames is the rotor. The rotor is composed of a coil of wire known as the field winding. There are also iron segments with interlocking fingers that produce the magnetic poles while the AC generator is in operation. A pair of copper slip rings that are connected to the field winding, and a shaft that runs through these components and holds them together. Because of its similarities in appearance to a claw, it is often called a claw-pole rotor design. The rotor is coated with a protective layer of varnish to keep out moisture and prevent the windings from shifting as the rotor rotates. The rotor is supplied with direct current from the vehicle's battery, and when energized becomes a powerful electromagnet. On its way to the rotor, current passes through a pair of brushes. These rest against the slip rings, and through them flows a regulated DC current. They maintain contact with the rotor by springs inside the brush holders. The brushes carry only the field current, usually less than 5 amps. This low current minimizes wear on the brushes. Current flows through one brush and into the slip ring, into the field winding of the rotor, and leaves the field coil through the other slip ring and brush and returns to the battery.
Hey, Mr. Pye.
Yes.
The field winding consists of many
What's that?
So, How do the alternator know when to push down on the brushes?
Oh, it maintains that pressure all the time. It's got springs in there. They're spring loaded.
Right, so the brushes never wear down.
Oh, they wear down. They wear out.
But so that's when you need to replace the alternator.
Right.
Okay, all right.
Of wire wound over an iron spool. When current is passed through the field winding, an electromagnet is formed, and a magnetic field is produced. The amount of current in the field winding has a direct bearing upon the strength of the magnetic
Are we gonna watch this movie?
field of the rotor. A certain residual magnetism is always present in these pole pieces. But by controlling the current entering the rotor field winding, the output voltage of the AC generator can also be controlled. The AC generator is described as being externally excited because current is supplied from the battery. Battery current is directed through the circuitry of the voltage regulator. The iron in the rotor's construction greatly concentrates the strength of the magnetic field, as much as 2,500 times greater than if it were made of a non-ferrous material. The rotor assembly is designed so that the direction of current flow in the rotor field winding produces a north magnetic pole in one half of the rotor segment and a south magnetic pole in the other half of the rotor segment. As the engine runs, its rotational force is delivered to the rotor by a drive belt and pulleys. Inside the AC generator, the rotor spins within the stator. The stator is made of a laminated iron frame and a series of windings. There are a total of 3 separate windings in the stator. The stator windings are a series of loops that fit into slots in the stator frame. The clearance between the rotor and stator is very small. This allows the magnetic field of the rotor to interact most strongly with the stator windings. While the engine runs, voltage is produced in the stator. The greater the speed of the rotor, the higher the voltage induced within the stator windings. Movement of the rotor will alternately allow each pole finger to pass each loop in the stator windings. This induces a voltage, which creates current flow in the stator windings. The stator laminations are insulated with an epoxy coating prior to installation of the windings. The assembly is then varnish coated for added insulation and also to prevent movement of the windings. The stator assembly can be found sandwiched between the opposite ends of the AC generator frame. The stator can be one of 2 types, delta wound or Y wound. The delta stator has its coils connected together so that the 3 coils form a triangle. The stator leads are tapped into the 3 points of this triangle. The Y-wound stator has its coils wound so that it takes the form of the letter Y. The 3 leads are tapped into the 3 ends of the Y. It can be identified by the presence of a splice, which is the center point of the Y. The electrical characteristics of the 2 types of stators are different. The Y stator has the potential to produce a higher voltage at a given rotational speed, while the delta or triangle stator will produce a higher current.
What type of current is produced with the delta type stator? Alternating current or direct current?
Good, you're right. As the rotor spins inside the stator, alternating current is produced. This current must be converted to direct current to be used by the automotive electrical system. Converting alternating current to direct current is known as rectification. The AC generator uses a diode assembly called a rectifier bridge. There's generally a pair of diodes for each winding in the stator. The diodes are mounted in a heatsink designed to dissipate the high temperatures developed during rectification. Each pair of diodes divides the alternating current into two paths, one positive and one negative. Diodes are commonly called one-way valves. A diode allows an electrical current to travel in only one direction. When the polarity of the current is reversed, the diode will block the flow of current. Two terms are used to describe a diode's ability to allow current to flow and to block current: forward and reverse bias. When the diode is conducting current, it is said to be forward biased. When the diode is blocking the flow of current, it is said to be reverse biased. A diode has two parts: a positive or anode side and a negative or cathode side. The diode will conduct if the anode is more positive than the cathode. For example, diodes typically used in rectifier bridges will forward bias if the anode is more positive than the cathode by about 0.5 to 0.7 volts. The diode will block current flow if the cathode is more positive than the anode. The diode symbol indicates the polarity of the component. The arrow in the diode symbol always points toward the more negative potential if the diode is on or forward biased. There are usually 6 diodes used to rectify the 3 phases of alternating current produced in the stator. 3 diodes are mounted with their anode to the heatsink, and 3 with their cathode to the heatsink. The 3 diodes mounted with their cathodes to the heatsink are mounted so that the heatsink is insulated from the AC generator's body and are the positive connection to the battery. The other 3, with their anodes contacting the heatsink, are designed to be in contact with the AC generator's frame and serve as the connection to the negative battery terminal. The key to understanding the process of rectification is to keep in mind that the diode will conduct when the anode is more positive than the cathode. It will block when the cathode is higher than the anode. In the Y-type stator, the windings form a series circuit. 2 of the windings are always producing a voltage together. Each arm of the Y stator produces about 8 volts. But when the arms are placed together in series, they produce 16 volts. One point of the Y is at 16 volts. Another is at 0 volts. And the third arm of the stator will be at approximately 8 volts. As the rotor turns, these voltages switch from one arm of the Y to another. In each position, the point of the arrow indicates the highest voltage, while the end of the arrow indicates the 0 volt state. Let's look at a schematic representation of the stator and diode assembly. The diodes are labeled with the numbers 1 through 6, and the Y stator ends are labeled A, B, and C. In the first position, stator output is 16 volts at the B end of the Y. The circuit is completed through diode number 4, where it is forward biased and connected to the positive terminal of the battery. Diode number 1 is also forward biased because the negative battery terminal is actually more positive than the stator end A of the Y. In the next position, stator output is 16 volts at the C end of the Y. The circuit is completed through diode number 6, where it is forward biased and connected to the positive terminal of the battery. Diode number 3 is also forward biased because the negative battery terminal is more positive than the stator end B of the Y. This process will continue through the other 4 current paths. In each path, only 2 diodes will be in forward bias. All the other diodes are in reverse bias and will block the flow of current. The voltage obtained from the stator rectifier combination is so smooth that for all practical purposes, the output is considered to be a non-varying DC voltage. If an oscilloscope is used to monitor the AC generator's output, current will be represented as a series of overlapping arches. This represents the peaks of the three phases of rectified AC produced by the unit. AC generator output can never be perfectly smooth because it is obtained from the rising and falling phase voltage curves. This gives the output of a properly functioning AC generator a characteristic ripple. Some AC generators use a capacitor, which is designed to absorb high voltage spikes that could possibly damage the voltage regulator and cause a whining noise in the radio. In the next video, we'll take a look at how we can troubleshoot the charging system. Now, let's look at the key segments of the video. The AC generator's rotor is supplied with direct current from the vehicle's battery, and when energized, becomes a powerful electromagnet. As the rotor spins inside the stator, alternating current is produced. This current must be converted to direct current to be used by the automotive electrical system. Diodes are commonly called one-way valves. A diode allows an electrical current to travel in only one direction. In the Y-type stator, the windings form a series circuit. Two of the windings are always producing a voltage together. If an oscilloscope is used to monitor the AC generator's output, current will be represented as a series of overlapping arches.
Let's check your understanding.
Probably won't work, but let's try.
When viewed on an oscilloscope, the output of a properly functioning AC generator